points get flipped. Okay, that's an important point to help you graph these things. The inverse can be graphed by reflecting it about the line y equals x. That's just sloppy. Let me write that in again. Reflecting. Maybe I needed to leave more space. It about the line y equals x. So one thing to be careful of, sometimes your provincial examiners are going to tell you the function has been reflected along the line y equals x. They're not going to say, we put an inverse function here. They're going to use this little code of reflecting on y equals x. You need to remember that means the same thing. So if you're doing transformations and all of a sudden the next step you come to says, now reflect your graph on the line y equals x, they're telling you to do the inverse. They want to know if you understand that. Okay, so this is equally as important to know as the inverse, that it does reflect on y equals x. So the notations that you're going to see, the first notation, it comes from switching x and y. Normally you're used to seeing y equals f of x, like that. Now you're going to look at it as x equals f of y. The flipped version, so when you see the coordinates flipped, you think inverse. Okay? The other one is the tricky one. I hate it when they do this on the exams because it confuses students. It shouldn't be confusing, the f inverse of x. But sometimes students see that little -1 and they think that means -1 exponent. Kind of like if I went like this, some of you might go like that. Okay? This never ever means what I just did in Math 12. 100% of the time it means inverse. The problem is, if you go from this one to this one, that's a different graph. We're going to learn about this one later in our unit. So students switch them by mistake sometimes. Okay? 100% of the time, this means inverse. I know I'm telling you this, but I'm going to tell you right now that come June and we write our final and I sit down to a big stack of papers, and I love doing that, and I'm flipping through, I bet you 2 of you are still going to do it, even though I've said don't. So don't let it be you, okay? But if it's f inverse, 100% of the time, that means inverse, not this one, which we'll look at later. Okay? Okay. So, I'm going to let you take a look at graphing this one on your own. Graph the inverse using what you know. Okay, so I'm going to do this one with you fairly quick. This is at the point 5, 5. So when I switch the coordinates, it stays at 5, 5. This is at the point 1, 5, which means it's going to the point 5, 1. Then this is at the point 1, 1, which is not going to change. So the next one is at the point -3, 1. It will now be at 1, -3. And if I do the last point here, this is at -3, -4. This will be at, flipped will be, sorry, is at -3. So at -3, -3, it will be, let's see here, -3, -3. Does that turn out okay? I think so, right? Say it again. At -3, -3, so it should be at, oh right, you're saying it's positive, so it won't move, thank you. Going too fast, my brain just shut down. So here's what your graph should look like. If you verify that, there's your reflection. If I do the same thing, that means this point here, I believe goes there. And let's see here, this is -3, +2, so +2, -3. I also use this point here just to give me some extra stuff. So that's -5 and 4, so it's going to go over to 4, -5. And then the final one I used here was at -7 and 2, so it's going to go to 2, -7. And if it's going to be a reflection, it's going to have to look like that.